Hi, welcome to Algebra 2 Common Core. Today we're going to be working with equations of circles in Lesson 12. It should be familiar because you did see some of this in geometry last year. We're going to start with the distance formula. So remember back to geometry that the distance formula means we want to find the distance between 2 points. So the 2 points I'm going to label as x1, y1, comma x2, y2. So I'll have two sets of ordered pairs here. The distance between those points can always be calculated by the square root of x2 minus x1 squared plus y2 minus y1 squared. You may have learned this last year in geometry as an application of the Pythagorean theorem. So we'll take a look at that in a few minutes on our picture in exercise 1. So exercise number 1 says a circle is just the collection of all points that are a set distance. And that set distance that we're talking about is the radius of the circle away from the point that is designated as the center of the circle. So I've got a picture here of a circle that has a radius of 5 and a center at the point 4, 2. So there's the point that I'm going to be focusing on for this example. So in part A, we want to use the distance formula to show that the point 7, -2 must lie on this circle. So to lie on the circle, that tells me that the distance between the point 7, -2 and the point that's designated as the center, 4, 2, must equal that radius of 5. So we're going to calculate the distance between those 2 points. Using the distance formula, this is going to be d is equal to the square root of. Now I'm going to go ahead and use, let's use the center as my first point, and let's use the point on the circle as the second point. So I'm going to say 7 minus 4. So notice that we're subtracting the x coordinates. Square that distance and add on the difference of the y's, -2 minus 2 squared. And we're hoping that our answer turns out to be 5. So let's do this calculation. The square root of 7 minus 4 is 3, so I've got 3 squared. -2 minus 2 is -4, so I'm going to square that as well. So I'm getting the square root of 9 plus 16. Now be very careful in this situation. We've got to follow the order of operations and make sure that we're adding first and then taking the square root. We cannot take the square root of 9 and add it to the square root of 16. So I've got to do the addition first. This, of course, would be equal to the square root of 25, and the square root of 25 is 5. So that checks. That tells me that the point 7, -2 must lie on the circle where the center is equal to 4, 2, and the radius is equal to 5. In part B, we're going to generalize this process, and we're going to say, okay, now instead of picking a specific point like 7, -2, let's call the point that we're talking about just xy. So you can see on my picture we're using any generic point x, y, and we want to make the formula using the distance formula for all points on this circle. So remember that we know that the distance is equal to 5 because that's the radius, that's the length of the radius on my circle. So I'm replacing d with 5. Square root of, instead of x2, I'm putting the coordinate x, minus x1, which is 4. Square that and add on. Instead of y2, I'm using y, minus the y coordinate of the center, y minus 2 squared. Now, the only thing I'm going to do to simplify this equation is square both sides of the equation. So squaring the 5, I get a 25. Squaring the square root, I get x minus 4 squared plus y minus 2 squared. This has a special name. This is called the center radius form of the equation of the circle. Clearly, we see that we had to use the center 4, 2 to create this equation, and we also had to use the radius, which was 5, in order to create this equation. And the other thing is I can take a look at my final answer, and I can always read off from this final answer what's my center and what's my radius, because this number is always the radius squared. Now, we can take this one step further by rewriting this equation and doing the algebra to expand it. So in part C, we're going to square both sides of the equation and create what is called the standard form of a circle. So we're going to have two different forms of circle equations that we're working with today. So work with me algebraically. I'm actually going to flip-flop my two sides here, so I'm going to start with x minus 4 squared plus y minus 2 squared equals 25. We know that x minus 4 squared means that we're going to multiply x minus 4 times x minus 4. Y minus 2 squared means that we're going to multiply y minus 2 times y minus 2. And on the right side of the equation we have 25. So do the double distribution with me. X times x is x squared. The outsides give me negative 4x. The insides give me negative 4x. And the last, negative 4 times negative 4, positive 16. Let's do the same thing with the y's. So y times y gives me y squared. Let's put a plus in between there. Minus 2 times y, minus 2 times y, and then negative 2 times negative 2, positive 4, equals 25. Let's finish it off by combining, let's rearrange my terms and combine like terms. So I'm going to start with my x squared term, and then I'm going to go to the y squared term. So I usually write this in the form of the squared terms first. Then I'm going to combine the x terms that are like terms. So negative 4x minus 4x is negative 8x. And likewise, negative 2y minus 2y gives me a negative 4y. Lastly, let's combine all of our constants. So on the left side, I've got 16 plus 4. That gives me 20. But I'm also going to subtract 25 from both sides. So 16 plus 4 is 20. Minus 25 is going to give me negative 5 equals 0. This is the equation that's called the standard form of the equation of the circle. So we're going to be working with both of those forms. Lastly, in part D, we want to show algebraically that the point 1, negative 2 must also lie on this circle. So I'm going to do just what I did in part A, or use the equation from part B, and I'm going to substitute that point in. In fact, let's go back to that equation from part B, this one right here. And let's substitute in my point. So I'm going to say 25 has to equal, my x coordinate is 1, so 1 minus 4 squared, plus my y coordinate is negative 2, so negative 2 minus 2 squared. And I want to see if I end up with that answer of 25. 1 minus 4 is negative 3. Let's square that. Negative 2 minus 2 is negative 4. We'll square that as well. So 25 does equal 9 plus 16. So that does check, telling me that 1, negative 2 must be a point on the circle. So we're going to be going back and forth between creating equations of circles, writing them in center radius form, and writing them in standard form. But then we're also going to take a look at, starting with standard form, can we get it back to center radius form so that we'll be able to read from the equation what our center is and what our radius is. So let's record both of these equations for a circle in the box at the bottom of page 21 in your notes. First of all, the center radius form. The center radius form is the one that is x minus h quantity squared plus y minus k quantity squared equals r squared. So for this, we know that the center of my circle is h comma k, and we know that the radius of the circle is equal to r. You might have to pause the video to record these equations. For the standard form, that's the equation that we get when we multiply out the center radius form. We also rearrange the terms so that we're putting the x squared term first, then the y squared term, then the x term, then the y term, and then the constant. And we always want to end with equals 0. You'll notice that a, b, c, d, and e can be any coefficients for those x and y terms, and e is going to be the constant term in my equation. So today's lesson is going to go back and forth between center radius form and standard form, so it's important that you really familiarize yourself with both. So I'm going to keep these equations here as we work with exercise 2 and exercise 3. First of all, in exercise 2, it says which of the following equations would have a center of negative 3 comma 6 and have a radius equal to 3. Now, because I'm given the center and the radius, that tells me that I'm using this form, the center radius form. So obviously, the first thing I'm going to look at are all equations with a radius of 3. Because my equation has to have the radius squared, I'm going to eliminate any choices that don't have 3 squared on the right side. So that means that choice 3 and choice 4 can't possibly be right because I need 3 squared on the right side. The next thing that I want to look at is my h and my k. So remember that hk stands for the center. Since my standard form since the center radius form always has to have x minus h and y minus k, we're really looking for the equation that has the factors with the opposite sign of h and k. So instead of x, I want to put a negative 3 in for h, so I'm going to say x minus negative 3. X minus negative 3 gives me x plus 3 squared. Same thing with the y, I want to say y minus 6, so that's going to be y minus 6 squared. So I'm thinking that choice number 2 is the one that I want so that I've got the right signs within those parentheses. Looking at exercise number 3, for these 3 examples, we're going to be given an equation. Notice that the equation is also in center radius form. So from the equation, I should be able to tell the circle's center and also the circle's radius. So starting with A, I'm going to see that the center has to be taken from the h and the k. So the center is going to be, again, remember, take the opposite sign here. The center is going to be the point 2 comma 7. The radius squared is equal to 100, so that tells me that the radius must be equal to 10. And this one is an integer, so I can stop right there. Now I would be able to graph that circle by starting at the point 2 comma 7 and going 10 in all directions. So I'd go 10 units to the right, 10 units to the left, 10 up, and 10 down, and then connect those 4 points around the center 2, 7 to get the circle graph. Let's go to part B. So for part B, I see that I'm going to make my center using this number and this number. Take the opposite sign, so I've got a 5 and a -8 as my center. The radius squared is equal to 4, so that tells me that the radius must be equal to 2. And for part C, my center is going to be -6, 5, but this time the number that stands for my radius squared is not a perfect square. And that's okay, we'll be able to deal with that. First of all, we'll say that the radius is equal to the square root of 18. But because the question said take our radius and put it in decimal form to the nearest tenth, I'm just going to go to my calculator and take the square root of 18, and I see that I'm getting the answer 4.2. Let's try exercise number 4, which is going to be a little bit more of a challenge for us. It says by completing the square on both quadratic expressions. So we'll notice that we have a quadratic expression with x's and we have a quadratic expression with y's. So we'll use the process of completing the square on both x's and y's in this example. We'll want to rewrite our equation, changing it from standard form over to center radius form. And that will allow us to find the center of the circle and the radius of the circle. So our goal here is to go from standard form of our equation over to center radius form. So let's go through the steps together. In the first part, we see that we have an x squared plus a 10x. Grouping my x terms together like this, I'm then going to leave a space where I'll complete the square with the x's. I'm going to write the y's the same way, so I'm going to say y squared minus 2y, and I'm going to complete the square with the y terms. Now you'll notice that this time the 10 is already on the right side of the equation, so I'm going to leave it there. If the constant were on the left side, at this point I would move it to the right side because I do want it on the right side. So let's go ahead and complete the square with the x's. So just like before our last two lessons, we're going to say let's take half of that coefficient of the x term, and then we'll square it. So half of 10 is 5. 5 squared gives me 25. So I'm going to add 25 right here. Now if I add 25 to the left side of the equation, I've got to keep equality here, so I add 25 to the right side of the equation as well. Now let's look at the y terms. My coefficient of the y is -2, so I'm going to take half of that -2, square that answer. So half of -2 is -1. We want to square that to equal 1. So I'm going to add 1 here and also on the right side. Now the biggest mistake that we sometimes make is to forget to add the numbers over to the right side as well. Now we want to look for our factors. So x squared plus 10x plus 25, that will factor into x plus 5 squared. Remember the little reminder that we used when we were completing the square before? The number that goes inside my factor is always the half number that I got back in this step. Let's do the same thing with the y's. So this is going to be y minus 1 squared equals, and now let's go ahead and add together all the constants on the right side of the equation. So that's actually giving me what? 36. So what we have now done is rewritten this equation in a more familiar way, the center radius form. So if it's in center radius form, I can just read the center right off of this equation. So I'm going to use this number right here and this number right here as my center. Don't forget to take the opposite signs like we did in the last exercise. -5, 1. This number, of course, stands for my radius squared, so that tells me that the radius is equal to 6. And again, I could go ahead and graph this by starting on my graph at the center, -5, 1, and then going 6 units to the right, to the left, up, and down. In exercise 5, we see that we have the same instructions as we did on the previous example. So we want to complete the square on both of the quadratic expressions to put the equation into center radius form. But unfortunately, I noticed that A is exactly the same exercise that we just did on 4. So we're going to cross that one off and proceed to part B. Now let's rearrange our terms a little bit here because we want to put the x terms together. So I'm going to say x squared minus 6x and then leave a spot to complete the square for the x's. Then put the y terms together, so we're going to say y squared plus 12y, and we're going to complete the square there as well. Now here's an example of one where we want to move that constant over to the right side of the equation by subtracting 36 from both sides. So that becomes a negative 36. Make sure you don't lose that negative sign. Now let's go ahead and complete the square. So I'm going to say take half of the negative 6, which is of course negative 3. I want to square that half number, and that gives me 9. So I'm going to go ahead and I'm going to add 9 to right here and also over here on the right side of my equation. Let's do the same thing with the y's. So I want to take half of 12 and square that. Half of 12 is 6, so 6 squared gives me 36. So I'm going to add 36 right here, and I think I got to fit it in right here on the right side as well. So now we're going to factor. So x squared minus 6x plus 9, that factors into x minus 3 times x minus 3, which is of course x minus 3 squared. Y squared plus 12y plus 36, that's going to be y plus 6 times y plus 6, which is y plus 6 squared. Now on the right side, look at how nicely this works out. Negative 36 and positive 36 cancel, so that leaves me with 9. So when I go from standard form to center radius form, it becomes really easy to read off the center. So the center should be the point 3, negative 6. And then, of course, this number stands for my radius squared, so the radius is equal to 3 for this circle. Now, I'd like you to try the you try it, and don't be concerned if you end up with a radius that doesn't turn out to be a whole number. You can just do what we did back in exercise number 3 and say, it's okay, we'll just take our radius as a decimal rounded to the tenths. So come back and check your work with mine when you're done. Welcome back. Take a look at completing the square for the x's. I got x squared minus 12x plus 36, so that factored into x minus 6 squared. Completing the square for the y's, I got y squared plus 4y plus 4, so that in factored form is y plus 2 squared. On the right side, I moved the 18 to the right, and then I added on 36 and 4. So that gave me 22 on the right side. Reading my center from the left side, I get that the center is positive 6, negative 2, and the radius squared is equal to 22, so therefore the radius is the square root of 22. If I want to put that on a graph, I would go to my calculator and see that that's approximately equal to 4.7. So check that over and make sure that yours matches. We're going to go on to one more exercise here where we're using this equation of a circle. In exercise 6, we're going to see more of an application problem where we're going to want to use the center radius form of our circle. Well, we're given some information and we need to come up with some additional information to make this equation. First of all, reading through the exercise, it says find the equation of the circle in center radius form. So make sure you see that we're going to leave it in center radius form. Of the circle with endpoints, I left off a couple words here. It should say endpoints of the diameter. And I've plotted these points on a graph. Negative 2, negative 4 is one endpoint, and 4, 4 is the other endpoint. And I see that I want to make the circle such that the diameter goes from one point, -2, -4, to the other endpoint, 4, 4. Now, in order for me to make the equation of this circle, I'm missing some information. So one important piece of information that I'm missing is going to be the center of the circle. Now, if you think back to geometry, if I know the endpoint -2, -4 over here, and I know the other endpoint 4, 4, I know that the center has to be halfway between the two. The word that we always used in geometry for halfway would be the midpoint. So we want to find the midpoint of the line segment that connects those two endpoints. Do you remember that for midpoint we always add our x coordinates together and divide by 2, and then add our y coordinates together and divide by 2 as well. So I'm getting that the coordinates for the midpoint will be 1, 0. Now that is going to be the point that makes the center of my circle. So on my picture, that's approximately right here. So now I'm going to go ahead and say, well, the other piece of information that I need is the radius for the circle. But honestly, it works out very nicely if I just go to my center radius form. So x minus h squared plus y minus k squared equals the radius squared. So one quick and easy way of getting the radius is to first of all plug the center in for h and k. So I've got x minus 1 squared plus y minus 0 squared equals the radius squared. Now I can go back and use either of these points because both points have to be a point on my circle. I'm going to use the one that has the positive values, so 4 and 4, and I'm going to go ahead and substitute 4 in for x and 4 in for y in order to solve for the radius of this circle. So I'm going to say 4 minus 1 squared plus 4 minus 0 squared equals the radius squared. Some of you might be thinking, could I also use the distance formula? And the answer, of course, is yes, but what we're doing is actually also a form of the distance formula. So this gives me 3 squared plus 4 squared equals the radius squared. And in fact, this actually makes a 3, 4, 5 right triangle, because we get 9 plus 16 equals the radius squared. So the radius squared is equal to 25. So r must be equal to 5. Technically, we just need the radius squared in order to be able to plug it into this equation. So my final answer in center radius form for this circle is going to be x minus 1 squared plus, I don't have to put the 0, so I can just say y squared, and in fact I don't need the parentheses either, equals the radius squared, which is 25. So this is the equation of my circle in center radius form, where the endpoints of the diameter go from -2, -4 to 4, 4. So again, just an application problem working with our forms of the equations of the circle. We've been doing a lot of interesting work on circles today, and we'll continue this work in class. Have a great night, and we'll see you next time.